Hello students, welcome back. Today in chemistry I will teach chapter 2, that is chemical bonding. In the syllabus you have three types of chemical bonds, that are ionic bond, covalent bond and coordinate bond with electron dot structures. In class 9th we studied electrovalent and covalent compounds with orbital structures of the compounds. Now for class 10th you need to learn electron dot structures. So let's start the chapter. Students, in your 9th class you have already studied about chemical bonding. So let's recall. What is chemical bond? Chemical bond is an attractive force which holds the atom together in a molecule. And what are the causes of chemical bonding? Every atom tries to get an inert gas electronic configuration. And why is it trying to get inert gas electronic configuration? Every atom needs stability. In these inert gases, starting from the helium, having 2 electrons in the outermost shell, K shell, and following the duplet rule, as K shell can have maximum of 2 electrons and become stable. Neon, argon, krypton, xenon and radon, they have 8 electrons in their outermost shell and they follow the octet rule. Due to this electronic configuration, these gases are stable and inert. Therefore, to attain stability, atoms tend to combine chemically by redistribution of valence electrons or the electrons in the outermost shell, so that each is having a stable electronic configuration, either the duplet or the octet. There are 3 methods in which atoms can achieve a stable inert gas electronic configuration. First, by forming ionic bond or electrovalent bond. Second, by forming covalent bond or molecular bond. Third, by forming coordinate bond or the dative bond. So let's start the first bond, that is the ionic bond or electrovalent bond. Students, can you tell me what is electrovalent bond? Because we have already done this in class 9th. Okay, see, it is a bond formed between the metals and nonmetals. Or you can define it as a bond formed by the transfer of electrons from one atom of an element to one atom of another element. Or it's a bond formed between cations and anions. Cations are positive ions and anions are the negative ions. Or you can say bond formed between electropositive element and electronegative elements. Make sure here in ionic bond there is no sharing of electrons. It is a complete transfer. It is a transfer of the electrons from one atom to another atom. Let us revise the properties of metal and nonmetal. Atoms of metallic elements have 1, 2 or 3 valence electrons, and they can transfer it to the nonmetals which have the valence electrons 5, 6 or 7, as nonmetals have a tendency to gain the electrons. After the transfer of the electrons from metal to nonmetal, both the combining atoms acquire the electronic configuration of the nearest inert gas. A metallic atom which loses the electrons forms the positive ion or the cation, and a non-metallic element which gains the electron forms the negative ion or the anions. So how will you going to define ion? An ion is a charged particle which is formed due to the gain or loss of one or more electrons by an atom. And ions are how many types? There are two types, cation and anion. Cation are positive charged and anions are negative charged. Now, electropositive elements are the metals and electronegative elements are the non-metals. So how will you going to define electropositive elements? It is a metallic element whose one atom easily loses electron or electrons to form a positively charged ion, is known as electropositive element. For example, lithium, sodium, aluminium, these are all electropositive elements. Electronegative element, a non-metallic element whose atom accepts the electron or electrons very easily to form the negatively charged ions or the anions, is known as the electronegative element. For example, nitrogen, chlorine, oxygen. Now, let us understand the ionic compound sodium chloride formation. Sodium having atomic number 11, it has electronic configuration 281. So 1 is in the valence shell. So this sodium will try to remove one valence electron and get into Na positive state with the electronic configuration 28. Now this 28 electronic configuration resembles to the stable inert gas electronic configuration of neon. Hence Na positive is very stable. Now Chlorine has atomic number 17 and electronic configuration is 287. Now this chlorine will try to gain one electron and get into a stable form. So this one electron is taken from the sodium atom. As sodium has released one electron is taken by the chlorine atom. Now this chlorine atom, after gaining one electron from sodium atom, get into a negative state, that is known as a chloride anion, and the electronic configuration becomes 288, which is resembling to the inert gas argon, that is having 288 electronic configuration. Now these cation and anion are stable. Now they are the opposite charged ions and they develop an electrostatic force of attraction between them and form a chemical bond. Now this chemical bond is known as the Ionic Bond. Since this chemical bond formation is due to the electrostatic force of attraction between a cation and an anion, it is known as an ionic bond or a electrovalent bond, and NaCl molecule is very stable. Now let's check the electrovalency. Electrovalency, the number of electrons that an atom of an element loses or gains to form a electrovalent bond, is known as electrovalency. So in the formation of NaCl, sodium is losing one electron and getting into a positive cation. So it shows a positive electrovalency. And what is the electrovalency of sodium in this? +1. And gain of the electrons shows the negative electrovalency. So chlorine gains one electron and get into a negative ion or the anion. So we can say chlorine shows the negative electrovalency of 1, -1 we can say. Students, what are the causes for the formation of an electrovalent bond? See, when an ionic compound is formed, the neutral atom is changed to a cation or the anion. The formation of cations and anions depend on few factors like ionization potential, electron affinity, electronegativity difference. In the last videos of chapter 1, we already did ionization potential, electron affinity, electronegativity difference. Here, these properties help in the formation of ionic bond. The first property is ionization potential. The ionization potential should be low for the formation of the ionic bond. So what is ionization potential? Please remember, ionization potential and ionization energy is the same thing. Ionization potential is the minimum amount of energy which is required to remove the most loosely bound electron from the neutral gaseous atom to form the cation. So, lesser amount of energy required, easier it will be to lose the electrons to form the cations. Hence, we can say low ionization potential of metals will favor the formation of the ionic bonding. Let's understand the second property, electron affinity. Now, electron affinity should be high for the formation of the ionic bond. What is electron affinity? It is the amount of energy released when an electron is added to the gaseous neutral atom to form a negative ion or the anion. Since the release of the energy is the sign of the stability of the system, so the atom with high electron affinity, that is, atom releasing high amount of energy while gaining the electron or electrons, forms the negative charge ion more easily. So, electron affinity of non-metal should be high in the formation of an ionic bond. Let us understand the third property, electronegativity difference. Now, this electronegativity difference should be large for the formation of the ionic bond. As we know that ionic bond is formed between metal and non-metal by the transfer of the electrons, the metals of group 1, 2 and 13 have a tendency to lose valence electron or valence electrons because of high electropositive nature and less electronegative nature. By losing the valence electrons, the metal combine with non-metals of group 15, 16 and 17, which have a tendency to gain the electrons because of their high electronegative nature to form the ionic bond. So, if the difference between the electronegative values of metal and non-metal is large, then it will favor the formation of the ionic bond. Let us understand with an example. Formation of NaCl, which is an ionic compound. Electronegativity value of sodium is 0.9, which is very less because sodium is electropositive in nature. Electronegativity nature of chlorine is more, that's why its value is 3. If we try to find out the difference between the electronegative values, it will be 3 minus 0.9. It will be 2.1, which is a very large electronegative difference. Hence, it forms the ionic bond and NaCl molecule is very stable. Here I have taken another example of cesium fluoride to understand that the large electronegative difference favors the formation of the ionic bond. Students, please note that the strongest ionic compound is cesium fluoride. This is very important. Please remember this. Now let us discuss why cesium fluoride is the strongest ionic compound. If we see the location of fluorine in periodic table, it will be on right side of periodic table and it is the first member of the halogen group. You must be knowing the halogen group is group number 17 and fluorine is in the period 2. Hence, fluorine is in group 17 and period 2. And we have studied earlier that electronegativity increases from left to right. Right? That is, from metals to non-metals, electronegativity increases. Now, let's see the location of cesium in periodic table. It is on left side and placed down in group 1 and period number 6. As we all know, the metals have a tendency to lose the electrons because they show less electronegative nature and more electropositive nature. On the other hand, non-metals, they have a tendency to gain the electrons because of high electronegative nature. So, across a period from left to right, the electronegativity increases. So, tendency to attract the electrons also increases. And down the group, the electronegativity decreases. So, tendency to lose the electrons increases as we go down the group. Hence, cesium is the most electropositive in nature and fluorine is the most electronegative element. That is why cesium fluoride is the most ionic compound. Let us check with the help of the electronegative values of cesium and fluorine. The electronegativity values of cesium is 0.7, which is very low because cesium is electropositive in nature. Electronegativity value of fluorine is 4, which is highest electronegative value of fluorine. So, electronegative difference will be 4 minus 0.7, that will be 3.3. Now, this difference is very large difference. That's why it favors the formation of the ionic bond between cesium and fluorine. Hence, cesium fluoride is the most ionic compound or the strongest ionic compound. Students, why are ionic compounds stable? See, the ionic compounds are formed by ions that are cations and anions. Now, in between the like charges like cation and cation or anion and anion, there exists a force which is called a repulsive force. As we know that the same charges repel each other. But there exists an electrostatic force of attraction also between the opposite charges, which is much higher than the repulsive forces of like charges. Thus, it makes ionic compounds stable. There are few examples of ionic compounds like sodium chloride, magnesium chloride, calcium oxide, potassium bromide, calcium chloride. Now we will study the structure of electrovalent compounds. In your syllabus, there are 3 ionic compounds, namely sodium chloride, magnesium chloride and calcium oxide. And you have to learn their electron dot structures. As you all have studied the orbital structures of these 3 compounds in your class 9th, here for class 10th, we will focus on electron dot structures. Students, are all the electrons present in all the orbits taking part in the chemical reaction? Or we can say chemical bonding? No, only the valence electrons or electrons which are present in the outermost shell are taking part in the chemical bonding. So, Lewis gave a concept of dot diagram in which only the valence electrons are shown. And there is electron dot symbol also for an atom consists of the symbol of the element which is surrounded by the valence electrons. The paired electrons are shown by a pair of dots, two dots showing a pair, whereas the unpaired electron in the outermost is represented by a single dot. So over here, to show the electron dot structure, you need to write the symbol of the atom. Like for hydrogen, you will write H, oxygen, you will write O, for magnesium, Mg, and so on. And the valence electrons will be shown. Atomic number of hydrogen is 1, so valence electron also 1. Atomic number of oxygen is 8, electronic configuration 2, 6. 6 valence electrons will be shown surrounding the symbol of the oxygen. So this is the electron dot symbol. Now let us understand the formation of sodium chloride molecule. Sodium atom, as you all know, has atomic number 11 with electronic configuration 281. When it combines with the chlorine atom, then it has a tendency to lose one valence electron and form Na positive ion or Na positive cation with electronic configuration 2,8, which is very stable. Chlorine has atomic number 17 with electronic configuration 287. Now these 7 valence electrons will try to make itself 8 by accepting 1 electrons and getting into a negative state, that is Cl negative or chloride ion or anion with electronic configuration 288. You can see here 288 and sodium ion 28. So the extra 1 electron of the sodium has been transferred to the chlorine atom. Thus they form 2 ions, sodium ion and chloride ion. These oppositely charged ions will develop electrostatic force of attraction, or you can say the Coulomb's forces will be developed in between the charged particles, and they form a chemical bond which is known as the Ionic Bond. So this is the way to show the formation of the sodium chloride with the help of the orbital structure. But in your course you will be learning the electron dot structure of the NaCl. So you will be writing the symbol of the sodium, that is Na, and valence electron, 1 valence electron. You can see 1 valence electron here, and plus chlorine atom with 7 valence electrons. With 7 valence electrons will be shown surrounding the chlorine symbol. Then 1 valence electron will be transferred to the chlorine atom, and hence Na becomes Na positive and chlorine atom will have now 1, 2, 3, 4, 5, 6, 7, 8. Full 8 electrons and with a negative charge. So Na positive, in a bracket you can show chlorine with all 8 valence electrons with a negative charge. So this is the way to show the formation of NaCl with the help of electron dot structure. Students, as you all know, the atoms are electrically neutral. It means that the number of electrons and number of protons are equal in it. But when an atom changes to an ion, either positive ion or a negative ion, then they have either less electrons or more electrons than the protons. Due to this reason, they show difference in their properties. So let's compare the properties of sodium atom and sodium ion. The first property is color. Sodium atom is silvery white, but sodium cation is colorless. Toxicity: sodium atom is poisonous and sodium cation non-poisonous. Chemical action: sodium atom is very active because its electronic configuration is 281. It tries to lose its 1 electrons during combination. So it's very active. Sodium cation is inactive because it is Na positive. It is stable electronic configuration, that is 2,8. Valence shell: sodium atom has incomplete outermost shell and sodium cation has complete outermost shell by having electronic configuration 2,8 of sodium cation. Electrical state: sodium atom is neutral, means number of protons equals to number of electrons. There is no charge on the sodium atom, neither positive nor negative, so it is a neutral atom. Electrical state for the sodium cation, as you can see, it is Na positive, so it is having positive charge. Existence: sodium atom tries to attain the stable electronic configuration, so it chemically combines with other to attain the stability. So it is found in combined state. For example, sodium chloride. Sodium cation, as sodium cation has electronic configuration 2,8, it is highly stable, so it can exist independently. Let us compare the properties of chlorine atom with the chloride ion. Color: chlorine atom yellowish green, chloride anion colorless. Toxicity, chlorine atom poisonous, chloride anion non-poisonous. Odor, chlorine atom suffocating odor, chloride anion odorless. Chemical action, chlorine atom very active because electronic configuration is 287. It tries to take one electron to get into a stable form. Chloride anion is inactive because it is a stable ion with a electronic configuration 288. So it is inactive. Valence shell, chlorine atom, incomplete outermost shell having 7 electrons. It tries to take one electron to make it 8 valence electrons. Chloride anion, they have complete outermost shell. Chloride anion has electronic configuration 288. So complete outermost shell. Electrical state, chlorine atom is neutral. Chlorine atom, you can see there is no charge on it, no negative charge, so it is neutral. Number of the protons and number of electrons are equal. In the case of the chloride anion, it has a negative charge, means number of electrons are more than the number of the protons. So it is a negatively charged. Existence, chlorine atom is not independent. It is found in a combined form because chlorine tries to attain inert gas electronic configuration by adding one electron to its outermost shell. So chlorine atom is found in a combined form, like for example magnesium chloride, sodium chloride, etc. Chloride anion, it is independent. Why it is independent? Because it is stable with the electronic configuration 288. In my next video, that is part 2, we will be studying the formation of magnesium chloride, formation of calcium oxide, redox reaction, and properties of ionic compounds.